Hello, everyone. Sorry for the delay, technical issues. So, because Michael cannot be here today, I will talk on behalf of him. So, my name is MileyFu. I'm a CNCF ambassador, and we have a CNCF project called the Wasm Edge. So, we are using WebAssembly on the server side. And also, it can be used for AI inference. So today, I'm going to mostly talk about Rust. We will explore how Rust is used to build a highly reliable AI infra. And then the second part, we will talk about how the latest agent advancement, I don't know if you have heard of it, it's called the code mode. So to enable AI agents to write and verify Rust code themselves. So this is a survey by Stack Overflow in 2024. So as you can see, there are over 16,000 respondents has taken the survey. And if you look at Rust, it has been over 80%. And it's been the most beloved programming languages every year since 2016. But it's not the most desired one. You can see the most desired one are more languages like Python and JavaScript. That is because even though Rust has a very deep learning curves, so even though it's powerful, compilers would allow you to the compiled code would work, but it's very hard to because the compiler would force you to write correct and optimized code from the get-go. So, but for Python and JavaScript, it's popular because these two languages would prioritize the ease of writing over guaranteed correctness. So we are going to say that Rust is very good for AI infra, and we have written some AI infra projects with Rust ourselves. So this news, you must have heard of it. The memory safety of Rust is a really critical advantage. The White House urged the use of memory-safe programming languages, and it's very important for improving digital infrastructure. That's been really critical. And Elon Musk's xAI, that company has been using Rust to build its infra. So their engineering team has a custom training and inference stack based on Kubernetes, Rust, and JX. Rust is the ideal choice for building scalable, reliable, and maintainable infrastructure. So it prevents the majority of bugs typically found in distributed systems. And Rust would provide us with confidence that any code modification or refactor is likely to produce working programs that will run for months with minimum supervision. So these are supposed to be 2 demos I recorded this morning. So because of the jet lag, I woke up at 4 a.m. and recorded 2 demos. But as you can see, there's some technical issues. I will play the 2 demos when I exit this presentation, like at the end of the talk. Okay, so that's 2 voice agent demos built with, actually I have brought the device with me as well, but I'm very worried about the reliability of the network, so I won't do a live demo, but I have another talk tomorrow. If you go to the other talk of mine tomorrow, you will be able to see I will do a live demo, like together with my co-speaker, Saim. Yeah, so today I'm going to just play the recorded demo. So EchoKit is an example of a voice AI agent powered by a Rust server. Also, I will talk more about how it's structured tomorrow in the other talk. But apart from this EchoKit, yeah, I guess the next slide would, we have a bit of diagram to show how it works. So we built this, so that's the server orchestrating all the LLMs like ASR, LLM, and TTS. But we also have built with Rust another firmware. It's also open source. So that would talk, is like a minimum operation system that talks to the device. So right now we are supporting ESP32, and we are porting it to Raspberry Pi as well. So for the software part, as you can see in the diagram, it's first start when the user start to speak. So when the user start to speak, the device would send the raw voice data over a WebSocket. And so the server's first job is VAD, so it determines the audio stream when you have finished your turn of sentences and decide when the user has finished speaking. So it's very critical for a natural feeling conversation. And when the user finishes, the server would make its first API call to the ASR voice-to-text service, and then it takes the text and adds the chat history and custom prompt that you enter yourself, and then call the LLM. And the LLM might return a tool call. So if it does return a tool call, the server would intercept this tool call and route it into an MCP server. So it can search the internet or call other MPC server or like query a databases, etc. So with the text answer, the server would call the TTS, so text-to-speech service, and finally it would stream the new voice data from the TTS back to the device speaker. So this entire sequence is managed by a Rust server. So this suggests that you could also add, because it supports add-on sensors and controllers, so you can also add a camera or other visual-related like sensors to the device in the future and integrate that visual data stream into the AI agent's workflow. And also using MCP capabilities. So that's a GitHub link. Llama Edge is built on top of Wasm Edge, so it's what we have been talking about. Is mostly written in Rust, and we are using the Wasm runtime to run AI inference across platforms. So on the runtime level, we supported different underlying infras and operation systems, etc. And you are able to, as long as your AI application runs in one device like Mac, you will be able to run it across other devices. So that's Rust is great for code mode. That's the second part I'm going to talk about. So traditionally, AI agent would directly expose MCP tools to the large language models, and that would result in excessive token consumption from tool definitions and some intermediate result that pass through the model's context window. So that kind of traditional method of direct tool calling would not scale very well. So LLMs would be often overwhelmed with tool choices. So code mode, this is a new approach that would convert MCP tools into a programming language API, like such as TypeScript to allow LLM to write code to call the tools in a secure sandbox environment. So that would significantly reduce the token usage and improve tool composition and control flow. So Cloudflare has written an article about that. So it uses lightweight V8 isolates for this secure code execution. And Anthropic has emphasized this method would facilitate progressive disclosure of tools and would enable privacy-preserving observation. So the core problem here would be excessive, like I mentioned, excessive token consumption. So as you can see in the screenshot, it's a large amount of tokens being consumed. The MCP tools would consume 44.5K tokens. So the tool definitions would overload the context window, and that takes up 22.2% of the total context window. And also, intermediate tool results, intermediate tool would have wasted tokens. So in the traditional approach, for a large document, like some transcript, it would flow through the model's context twice just to be copied from one tool output to the next tool input. So that's not a very good way compared with code mode. So why code mode? So as MCP usage scales, there are two common patterns that can increase agent cost and latency that I have mentioned: the tool definition overload and the intermediate tool result would add your token consumption. And the idea behind the code mode is that LLMs are better at writing code to call MCP than calling MCP itself. So LLM should write code to call MCP. So it has seen a really large amount, because when LLMs are trained, it has seen quite a large amount of real-world code, like TypeScript, but like in their training set. But tool calls are not that common when they are trained. So for tool calls, it's mostly synthetic training set. So it cannot, it probably would not do as good as do a direct MCP calling than just writing code to call MCP. So what is code mode? So MCP tools are RPC functions expressed in JSON format. So it's far more efficient to use regular code like TypeScript or Rust for functions rather than JSON. So code mode would involve auto-generating an SDK for MCP servers, or adding SDK instructions or documentations, and providing a code mode MCP tool to execute the generated SDK code. And MCP is designed for tool calling, but it doesn't actually have to be used that way. So the code mode would argue that the tool that an MCP exposes are really just an RPC interface with attached documentation. We don't really have to present them as tools. We can take the tools and turn them into a programming language API instead. So that's the code mode implementations. That's three on the screen, 3 implementations. So the first is to auto-generate a SDK for a collection of MCP servers, and second is to add SDK instructions, docs to the skill.md or system prompt, or third, to provide the code mode MCP tools to execute the generated SDK code. So the LLM would generate code that calls the SDK. So this code is passed to the specialized tool mode MCP and then execute it in a secure sandbox. So this sandbox can handle complex logic like loops, conditionals, etc. So you can see crucially, the code execution environment processes data like a very big spreadsheet, and only returns the final filtered result back to the model's context. So the agent can execute complex logic without alternating through the agent loop for every step. So Rust is uniquely suited for AI coders. So that's a podcast done by Brett Taylor. Like we know Brett Taylor is a co-founder of OpenAI, and he has, maybe not a co-founder, but he was on the board of OpenAI. So so he said that Rust's unique property would be really critical for AGI. So compiler being super strong would provide a tight feedback loop for AI. So this loop would serve as a very good reward function. And also, it would have very verifiable correctness because the compiler would force it being structurally oriented towards verifiable correctness, and that's what we need from an AI-generated program. So experts would argue that you should prefer a program written in Rust over in Python because it's run more efficiently and is certainly safer. And once a Rust project compiles, there's a high likelihood it's going to run correctly as intended. So if the path to AGI would come from code generators, Rust is the best language for AI coders to use. So the code mode MCP tools, these are 2 MCP tools that we developed in our RustCoder project. So it's also an open source project. I will show you so that's this project. This is a GitHub link. And so what does these 2 MCP tools do? So the first one, generate, is to generate a complete Rust source code project from a description, like from your prompt. And what's more important is the second one. So with compile and fix, you would be able to compile the code and automatically fix any compiler errors. And it's a self-correcting and self-improving cycle. So it would constantly improve itself by taking its errors and see how you fix it and get better and better. Yeah. So this is the RustCoder project that would help you better write Rust code. It would use LLMs to create fully functional Rust cargo project. So this system would rely on an integrated stack of several fine-tuned tools. So it has, like I said, a self-improving knowledge base of Rust compiler error messages. and how to fix them. So the execution would use a system like Llama Edge, like I mentioned just now, to run optimize the LLMs, such as like code optimize. So like the Quen coder or other open source models in a packaged solution. So here you can see the agent calling the generate tool and the compile and fix tool. So it can automatically fix bugs. That means the agent can work with the compiler until the code is correct. So this process would enable a very good long-term benefit. So that is, an agent could generate Rust code to like direct a drone's flight behavior, or and like during the process, it can automatically compile and debug it until it works. And then until it really works, it would upload it. And all those processes would be done without any human interventions. But it would have reasonable guarantees of correctness. Yeah, so this is the code mode approach can offer a glimpse into how the agent can efficiently build very high performance software. And yeah. So, actually that would be that goes faster than I thought because I haven't played the demo. So this would be the voice AI agent talk I mentioned. So I'll do it tomorrow at 2:15. And for today, I have a Water Manage project booth. So yeah, welcome to visit us and interact with the voice AI agent. We have a hardware device. I also have the hardware device on me today. So if you want to try it now, you can approach me later after the talk. So right now I will play the, yeah, I guess I will exit and play the 2 demos I recorded this morning. So, too many. Yes. Oh. It's not displaying, right?
Hi there.
Hi, please tell me something extremely interesting about Atlanta.
Absolutely.
It's not showing. Yeah, I guess I will just play the voice. Hello, who are
Not
you?
just the lips.
Oh, hello,
It's a
darling.
joy to be
I'm
here
Marilyn.
among your
Well,
bright
knowledge.
minds and generous spirits. But something beautiful with your technology, your arch, your quiet strength. I, a dreamer made of light and memory, feel right at home. Keep shining, darlings. The future is soft, and it's yours.
Welcome to join our.
So yeah, that's I will go back to, okay, I think probably I cannot go back. But like as I said in the diagram, that is, you can swap every component in that, like you can swap the voice, you can clone your own voice, and the demo I played was the voice of Marilyn Monroe, and you can do your own voices, or like you can swap to certain LLMs, and you can add knowledge base and add MCP servers, and also you can swap the best performing TTS and ASR, LLMs, etc. So yeah, I guess that would be the end of my talk. If you guys have any questions, you don't feel free to, yeah, feel free to ask. It's just I'm just having so much trouble with the display. Hello, you have a question?
Yeah, I really liked your talk. Thanks for sharing your work. So you were talking about how MCP servers consume so many tokens that are all wasted on just writing these tool definitions in deep context. Have you validated whether this Rust approach reduces the number of context tokens that are used?
We haven't done benchmark, but I think it should be at least reducing it because you only need the result. You don't even need to put everything inside the context window. So it should be far more than like 70% or even bigger. Yeah. Okay. Yeah. I have the device with me, so if anyone of you guys want to try it out, you can come to me.